In this video, we're going to build on our influence diagrams to create spreadsheet models for outsourcing and for the break-even problem. Before we build spreadsheet models, let's talk about what makes a good spreadsheet model. Verification is the process of making sure your spreadsheet model is accurate and actually doesn't have errors in it. In order to make spreadsheets of high quality and avoid these errors, I have a couple of tips for you. First, you can improve the design and format of the spreadsheet through how you set it up. Just like we identified on the influence diagrams, you want to separate your inputs, your model, and your output sections. This will help to make the flow of the spreadsheet more clear. Also, when you're building formulas in a spreadsheet model, you always want to reference input cells. That means never directly typing in a number, always using a cell reference. If there are lots of steps to a calculation, it's always worth it to break the formulas down into multiple steps instead of having super long formulas that are hard for other users to understand. It's also essential you label all the numbers you've included in the spreadsheet model so people know what value is represented. And you can also use color to help you separate values and sections in spreadsheets. When you're making your spreadsheet model to help reduce errors, you can check that the model is working with simple numbers or known results to see that you get the results you think you will from your mathematical equations. If you're using copy or paste, you have to be really careful it does not break your formulas, especially if you're using relative versus absolute references. You want to make sure you're still referencing the correct cells. When you're building your formulas, you might want to consider using your function buttons and wizard to help you to choose and set up formulas correctly. There's also many tools for formula auditing here, like showing formulas, error checking, evaluating, looking at precedence and dependence in the formula that will help you to make sure your formulas are error-free. Finally, to make sure that your workbook is working correctly and make your workbook as user-friendly as possible, some recommended tools to use are number one, data validation. Data validation allows you to set controls over certain values. So for example, if you're working with money and you don't want somebody to be able to enter a negative amount, you can use data validation to control that. Also, if you're working with text-based inputs and you want people to only be able to enter certain values, like if they were entering if a person is male or female, you could make a drop-down list that people can choose from in order to reduce typing errors. Another thing to use under the formulas tab is range names. If you name a cell with a specific name instead of something like B28 or C26, then it can help your formulas to look like real mathematical formulas you write on paper instead of just cell references in Excel. And finally, another tip to use is form control. You might have learned about form control in the past when you learned about macros in Excel. Things like buttons and spin buttons and scroll bars can help you to be able to quickly and easily change inputs in a model so people can see impacts of various different results on your spreadsheet model. So what we are going to do first is create a spreadsheet model following these tips for the outsourcing problem. Once we've created the spreadsheet model, we'll also add some data validation, range names, and form control in order to improve the spreadsheet model and make it as user-friendly as possible. So my first tip for creating any spreadsheet model is you want input, model, and output sections. So in my input section, I'll put the known values from the question. If I go back to the known values, we have this little mini table that had organized the values into what we know about in-house costs and what we know about outsourcing. So I can do the same thing in my spreadsheet model. So for in-house, oh, I'm just gonna have to change that back to black text. There we go. We had two different numbers, fixed costs and variable costs for in-house production of 50,000 and 125. In order to space this out a bit better, I'm going to put these amounts one tab in. This is actually a strategic choice that I'll explain why I do this in a minute. But basically it's to space out my numbers. And the fixed cost was 50,000, the variable cost was 125. And I just have my text set to white for some reason, but I just put it back in black and we can see it now. Might want to put all of this back to black text so that you can actually see the numbers. Then we're going to move on to the outsourcing section. Outsourcing. And for outsourcing, there was no fixed cost, so really all that matters was the variable cost. And again, outsourcing, variable cost, that number 175 is given to us. It's a dollar amount. And now we have included the fixed cost, the variable cost, and the variable cost. If we look back at our influence diagram, there was one more thing in the input section, and that was the number of units. So this question didn't specifically give us a number for units, but we can still include that in this section. We don't know the number of units yet, so I'll just leave it production volume. You could type in like 100 units. We'll try some different numbers like is recommended here. Try with simple numbers to make sure your formula is working. For my input section, I want to distinguish it from the output and the model. So you'll see I put the input section in the burgundy coarse color when I defined it here. So I'm going to put this as well in the burgundy coarse color. And then to be easier to see, that's why I had the white text. I'll put this as well with a whole thick outside border so it kind of stands out as its own section. Then we'll move to the next section, which is the model section where we have the calculations. From our influence diagram, the calculation should be the in-house cost and the outsourcing cost. Whoops, model. So in-house cost, outsourcing cost. So if we look at the influence diagram, you calculated in-house by doing fixed cost plus variable cost times units. So I can do fixed cost plus variable cost for in-house times the units, and that should give me the in-house cost. Whereas for outsourcing, it was just the variable cost to outsource times the number of units, because you wouldn't be responsible for any fixed costs when you're outsourcing. Those are my two pieces in the model section, and I put the model section in the dark blue. So now we've done this part, and the only thing left is the output, which is your cost difference. So for this, you could do, whoops, your in-house minus outsourcing, or you could do outsourcing minus in-house. It doesn't really matter what order you do it in, as long as you make sure you're consistent with that order and you know which order you're finding the difference in. So I'm going to do my in-house minus my outsourcing, and this tells me that because I did in-house minus outsource, that in-house is $45,000 more expensive. This one, because I said you could do the difference the other way around, like you could have done outsourcing minus in-house, and then it would just be negative 45,000. It can be important to help distinguish which one is the bigger one. To help you with that, you can make an extra output that gives you text instead of just a number that tells you whatever one is lower. So basically, whatever one is lower, you would want to choose. In order to get text back, you can use an if statement for that. So you could say, like, if in-house is bigger than outsourcing, then choose outsource. If it's not bigger, which is the not part, the value of false, that's when you choose in-house production. So in this case, because in-house is $45,000 more expensive than outsourcing, the best decision would be to outsource. But if you have a lot more units, I'll have to go even higher than that. higher again, like if you have 15,000 units, then it actually becomes more expensive to, or 1,500 units, sorry, it actually becomes more expensive to outsource than to make them in-house. So it changes the best decision. So you can use your output part of the model creatively to also give you words in addition to the numbers that can help you to make a decision. Because like I said, from the cost difference, it's one minus the other. But to know which one is the better one, adding those words in to tell you which one is less money would be your best decision to go with under these production variables. And to finish off my formatting, I'm just going to put a border around this and put this in my brown color that I was using for outputs. And that is my spreadsheet model for making a decision for outsourcing versus in-house production. You can see that my formulas are working, that if I change the number of units, it can change my costs and my decision. Whereas if I go back to fewer units, it changes the decision back to outsourcing. Here's my cost. For each of the scenarios, here's my best decision. Once you've built the model, let's work on adding some elements that will help us to make our model better. The first thing I'm going to do is add in some range names. What I mean by range names is where you have the numbers stored. Very important, it's where your number is stored, not your text. Instead of calling this cell like C29, like you can see in the name box here, you can give it a name like fixed cost. So that name will then appear in your formulas. If you want to speed up the naming process, on your formulas tab, there is this button, create from selection. What that means is if you select data like this, then all of the names in the left column beside the number, so if I click that button, see it says left column beside the number, that's the only one I want checked. It would give each of the numbers that name. So 50,000 would be called fixed cost. 125 would be called unit variable. 175 would be called outsourcing variable cost. 500 would be called production volume, etc. This is actually why I chose to indent the values by 1, because otherwise, if fixed cost was right below in-house, for example, then it might try to use in-house to name a blank cell with no number in it. So I put intentionally the ones I would later use for range names beside my numbers indented out to not just capture the overall names like input, model, output, in-house, outsource, etc. If I use this create from selection tool, now if I click on the cells like 50,000, you can see in the name box it's called fixed cost. The 125 is called unit variable cost. The reason that this is beneficial is if I go back and rewrite any of my formulas, like fixed cost plus unit variable cost times production volume, you can see the names of the cells now appear in the formula. So this actually looks like a mathematical equation that's easier to understand. Like if somebody new is looking at these formulas, they'll be able to more easily understand how you got these different values. For cost difference, you can actually put in-house minus outsourcing. That makes it more clear which one came first, which was the bigger one. And for your if statement, you can again try to make it more clear that if in-house is bigger than outsourcing, choose to outsource. Otherwise, make it in-house. And now if I go back to any of those formulas, they use the range names I created. You can make the range names using create from selection. You can also just click on any cell and type in the name box any name you want. I said any name you want, but there is some limitations. What I mean by that is you can't have spaces. You also can't use any of the names that are already used, like C26 is already the name of this cell, so I can't use C26 here, for example, in a cell that is not C26. So usually you want to choose a name that's related to what the value stored there is. You can't have spaces and you can't take names like D27 or B27 that are already taken by other cells. Once you've created names, you can also click the Name Manager button. This is where you could add new names to actually click a cell and name it. It's where you can edit names you already created if you wanted to change the name. or delete any names. If you have two names for the same cell by accident, you could delete one here. So this is where you'd edit any of those names you created. So range names are pretty easy to add to help your formulas actually look more like mathematical equations and make your spreadsheet models more easy to interpret. Another thing you can add is data validation. I'm just going to give you some examples here of what you could use for data validation. For example, in this model, there are some values that we shouldn't necessarily have decimals for. So, for example, for production volume, since that has to be a number of units, we should only be producing a whole number of units. So, if I don't want somebody to be able to enter something like decimals like this, I want to add data validation that a warning like this appears, that you have to be able to get a whole number. So that one's already pre-built in there, but the question is, how do I get that to show up, and how did I get that error? How you do it is you'll go to the Data tab and click this Data Validation button. Under Data Validation, I'm just going to clear this so we can start again from the beginning. For the production volume stored in C35, I would want to set it to be a whole number only. The minimum production you can have is 0 units because you can't have a negative number of units. And I'm going to go up to a maximum of 5,000. Let's say that's the most this company will ever need. They'll never need more than 5,000. For the input message, this is where you can actually write a message that tells people they have to enter a whole number. So I'll say this is for production volume, and my input message will be, you must enter a whole number between 0 and 5,000. And then error alert is how I got that X to appear that said, no, you can't enter a decimal. There are different styles. Stop will not let the person enter a decimal. Warning would give you a warning, but you'd still be able to say, okay, I want to enter a decimal if you wanted to. And information just literally shows up as like an information signal that you should not have entered a decimal, but it will still let you do it without stopping you. In this case, let's do a stop. I'll say production volume error. You must enter a whole number between 0 and 5,000 so that the person does not enter that, they'll get an error. So this is the input message. The error part is when they try to put in something that doesn't match that criteria. It could be a decimal, it could be a negative. And because I set it to stop with the X, they physically can't enter it. They'll never be able to enter a number that doesn't match the criteria. They can only enter between 0 and 5,000 with whole numbers. Anything other than that will give you an error. You could also set some other data validations, like for your in-house unit variable cost or outsourcing cost. You could set limitations on these. Some of the ones that are given as examples in the textbook are to set the unit variable cost to a decimal greater than 0. So you could do that, decimal greater than or equal to 0, and to set the outsourcing variable cost to a decimal but between 150 and 300. Maybe those were quotes they were given for outsourcing, so they know the outsourcing cost will always be between those values. It is recommended to put an input message, so you could say something like outsourcing costs, and you could say quotes were whole numbers between 150 and 300. And it is also recommended to set an error alert of some kind. This would tell the person that you need to enter between 150 and 300. So if somebody tried to enter like 120, it gives you that information error that it does let you enter it, which makes sense in this case because maybe you got a new quote for lower than the original ones. So it does let you enter it, but it does give you that information error warning that says originally it was supposed to be between 150 and 300. So that is data validation. That just allows you to control what people are entering into your model. This can be very, very important if you're dealing with things like volume that can't be a negative number and you don't want somebody to enter numbers that don't make sense and could give misleading results. Finally, if you want to test how your model changes, you can see I put in different production volumes like 100, 500, 1,000. You can see in-house and outsourcing are exactly the same there. 2,000, it switches your decision to in-house. So I'm trying all these different numbers, but there can be some faster ways to try out different numbers. Remember, for production volume, we said it should be between 0 and 5,000. This is where we could add form control to actually put in a button, or a scroll bar is the one I'm going to recommend, where we can try different numbers between 0 and 5,000. To do that, you'll have to have your developer tab. If you do not have the developer tab on your main ribbon, you'll have to add it in, going to File, Options, Customize Ribbon, and make sure the box is checked for the developer tab. It might not be if you've never used macros before, so check that box for developer, and then you'll definitely have that option. Once you have the developer tab option, click the Insert button, and this is a scroll bar. You'll see the little black plus sign appear. That means you need to drag out an area where we're going to put the scroll bar. Here we go. Once you've created this blank image for a scroll bar, right-click on it and go to Format Control. The current value is set to 0. The minimum set to 0. The maximum we want to set up to 5,000. The incremental change means it will go 1 unit at a time. Page change is just like for the animation, that it would go 10 units at a time. And for the cell link, we want to link this to our production volume because we want to see how production volume changes between 0 and 5,000 and how that changes the model. If you press OK, then click off. You must click off the image. You can literally drag it and see how between 5,000 all the way down to 0, should go down to 0 if I keep dragging, there we go, how it changes the decision between outsource and in-house. This would allow you to quickly look for the change point in your model where you switch between in-house and outsourcing as being the best decisions. It is recommended to help make your scroll bar easier to use. I'm just going to resize this a bit. It is recommended at the endpoints of the scroll bar to actually write down what the maximum and minimum values are. This will just help as somebody's scrolling for them to be reminded that they can't go beyond those values. And within the model is where you need to actually link the scroll bar to change the production volume here, because otherwise, if you don't actually link it to the model, if you use the scroll bar, it won't actually change the numbers in the model. So that's where the cell link is super important, to link this to the production volume that's actually in my model. I wanted to show you another option for possible form controls. So this one's called the spin button, and we're going to make a spin button for outsourcing unit variable cost. Right now it's 125, but as we did with the data validation, we got quotes between 150 and 300. So again, if you want to edit it, right click on the button, go to Format Control. We're going to vary it between 150 and 300 in units of 1. Again, I want to link this to my outsourcing unit variable cost so that as I go up and down, I can change it in my model. Often, people will put the number that's being influenced directly beside the button as well. I know it leads to some duplication, but just to let people know what number it's controlling. So that's an optional choice. You don't have to do that, but by putting it beside the spin button as well, then you can clearly see what number is being controlled and changed. Notice that I used this cell reference to do that. I actually clicked on the 175. That was my cell link in the model, because if you just type in 175, then it won't actually be connected to the button. You always have to go back to the cell references to get that connection. And this would allow you to see that if you have different possible numbers for the outsourcing cost, that can also change your decision in terms of which one is cheaper, outsourcing or creating in-house. So this is my outsourcing spreadsheet model, and I added some simple tools to help make it more user-friendly. Range names help my formulas to actually look more like mathematical formulas that are easier to understand. Data validation ensures that people can't add numbers that don't make sense, like they can't add a decimal volume or a negative one. And form controls allow you to just quickly look for changes in your model without having to type in all the possible production values. I can quickly scroll through them using tools like the scroll bar or the spin button. All that's left in this video is I want you to pause the video here to try to make your own spreadsheet model for the break-even problem. Then, once you've made the model, add at least one tool to make it more user-friendly. So that could be data validation, range names, or form control. You can add whatever one you would like of your choice. Please pause the video and I'll show you an answer for the model when you come back. Okay, so the first thing you want to do is make input, model, and output sections. For input, we had unit price, unit variable cost. Oh, I don't know why this one's merged. There we go. And again, I just had some white text from how I had it defined before. So I just need to put that back to black. And fixed cost and units. Just want to undo the merging so that if I use the range names later, then it will actually do it correctly without the merged ranges. So these are numbers that were given to me in the table here. Selling price, variable cost, fixed cost, and units. I'm going to put those numbers in. So selling unit price is $40. I can format that as $1. The variable cost was $24. 24. The fixed cost was 400,000 and the units were 40,000. So 400,000 and the units 40,000. The units are not dollars. Excel just tries to guess what you want because all the rest were dollars. So I'm going to put it back to just general, whereas these ones can all be in accounting format. There we go. So those are my inputs. I put them in my separate section, and I usually use burgundy for my input sections. So yours should look something like that as well. Then for your model section, if you go back to the influence diagram, we had total revenue and total cost. I would recommend separating these since they are separate elements. That for revenue, you should have something about the selling price times the units. That's how much money you would bring in. But for the costs, you have multiple pieces, variable and fixed costs. Together, they will give you the total cost. One of the tips for a spreadsheet was to break any complex formulas down into smaller pieces. So this one I actually separated the total variable, which will be the unit variable times the units, and the total fixed cost, which is just the 400,000. When I add those up, I'll get the grand total cost. You could have also computed this grand total cost in just one cell if you chose to do that. That's fine. As long as your formulas are correct and get you the same number, that's all that matters. So again, that's your personal choice, how you want to set that up in terms of if you want to do the variable and fixed separate or do the total in one shot in one single formula, as long as you understand that. And finally, the output from the influence diagram should have been the profit. So my last step for profit is I should have the total revenue minus the total cost. I think I'm just missing the cost here. There we go. And that would be the profit for this number of units. For my profit section, I'm just going to put it in the brown color I typically use for my outputs. So your model should look something like this. In terms of the choice of the tool, that one is completely up to you what you would like to set. I would recommend setting some data validation for the number of units because you can't have a decimal, it has to be a whole number, and you can't have a negative. So you could have between 0 and maybe like 100,000 units if that's the maximum they'll ever need. And then if someone tries to enter some kind of decimal, it won't work. For range names, I always recommend putting in range names. You could put them in for your input using create from selection again. Oh, the only issue here is that there's already one cell we use unit variable cost for. Here, unit variable cost. So maybe if you just call it variable cost. I don't think we have anything else called that. For fixed cost, we do have something else called that. So maybe you could say even BE for break even at the end. Otherwise, they will get the same name and you can't have two cells name the same thing. So if I do that, that it actually worked, that it's the unit price for break even, variable cost for break even, fixed cost for break even, units for break even. I could do the same thing in this section, create names from the left row. Then I get revenue, variable, fixed, and total costs. And finally for profit, I can name that one too. And if you want the names to actually appear in your formulas, you have to retype in the formulas, like revenue minus cost. And there we go. It would update to actually show my range names in my formula. And the last tool you could use would be, again, your form controls on the developer tab. Again, it's completely up to you because I didn't tell you exactly which ones you needed to input. You might have tried something like a scroll bar to look for varying the units. As I mentioned, let's say you can vary between 0 and 100,000, and we want to link that to the units. Oh, it says that the scroll value, the most it can go up to is 30,000. So if the most it can go up to is 30,000, we can link that to the break-even units here. And it's varying between 0 and 30,000. Our units were originally set to 40,000. So what you might want to do is I'm going to link this to a cell beside my scroll bar so that it's ranging between 0 and 30,000. And then in the real model, I'll take this number and multiply it by 10. Oh, retry. It's just not working with my data validation now. So I'm going to clear that just for a second to make sure it works first. So this number times 10, just so that I can actually get to 40,000 units. So really when the scroll bar is at like 4,000, that would get you to 40,000 units, the amount you had to have. And for break even, you'd specifically be interested in the point where you switch from a negative profit to a positive profit. So it's somewhere in this range between like 20 5,000 units approximately. Yeah, is the point where we switch from negative to positive profit and get to exactly 0, which would be the break-even point. So the scroll bar can help you with that, and it's just one option. You just might have to use some tricks with the scroll bar sometimes because the maximum amount it can go up to is 30,000. And this question had 40,000 units for the amount originally in the question. So by doing the times 10 trick, it kind of solves that problem of not being able to go above 30,000 with a scroll bar, but still allowing us to link more than 30,000 units in the break-even spreadsheet. This was a learning check question, so as long as you end up getting revenue, cost, and profit in those sections, you could organize it in different ways. You could have also added any possible options for data validation, range names, and form control. I just gave you a couple quick examples that you could add for data validation, the names, and a scroll bar option for form control. So in the next video, we'll look at some other tools you can add for what if analysis in your spreadsheet models, but we'll continue working with these same two examples for outsourcing and for break-even analysis. Thanks for watching.